Hello class, welcome to Algebra Lesson 6.1, Day 1, which is all about rational exponents and properties of exponents. Today we're just going to focus on the properties of exponents, but the goal of this entire 2-day lesson is to be able to use properties of exponents to solve equations with the rational exponents. All right, so let's quickly review some vocabulary. So when you have a number or a variable raised to a power, raised to an exponent. So let's say like 3 to the second or 3 squared. The entire thing that I just wrote is called a power. And then the 3 is called the base and the 2 would be your exponent. Okay, so this is just a visual. It can be any letter, any number for x, any letter, any number for the exponent. Okay, we're mainly going to look at exponents that have numbers in them today. Okay, so let's talk about rules for simplifying. These are really important to write down because if you don't follow these, you're going to get a lot of things wrong and you're probably going to get really frustrated. So make sure in order for your answer to be simplified, which everything needs to be in the simplest form, okay? It means that each variable only appears once. So if I have an x squared and an x squared or x cubed in a problem, I have to put these together so that way it's just x raised to a number, and I'll teach you more about that later. Okay, and then there can't be any power of powers. We're going to look at an entire example on what a power of a power is. All fractions must be simplified. So if I have something that looks like this, it needs to become this. Okay, so 4 over 6 would have to be simplified to 2 over 3. And 15 over 10 would have to be simplified to 3 over 2. All right, and then last but not least, you cannot have anything with a negative exponent. Okay, must be positive exponents. So now that we have those 4 rules for simplifying, let's move on. Let's first talk about our first rule, which is called product of powers. So in order to multiply powers with the same base, add their exponents. Okay, so look, I have the same base in this first problem. I have a b and a b. That means that I can take that b and I take my exponents and I add them together. So this would become b to the 7th, because I would just say 3 plus 4. Over here, I have the same base. It's an x. So I would say 5 plus 9, or x to the 14th power. If I have x to the 5th and y to the 5th, I can't do anything with that because my bases are different, okay? So it's really important to only add your powers, add the exponents for the same base. All right. Now, let's look at a problem that you guys will see. Something like this. So the first thing that you want to do with product of powers is first take a breath. For some reason, this chapter or this lesson, students see all the letters, all the exponents, and it makes them sometimes panic. Okay, so take a breath. Okay, and then let's talk about how to do this. So the first thing I recommend is take your regular numbers and you're honestly just going to multiply like normal. So -4 times -6, that becomes positive 24. Then I'm going to, look, I have an r, which whenever there's no exponent written, we assume it's a 1. So I have r to the 1st over here and r to the 5th over here. So I can take those and put those together. So 1 plus 5 is 6. So I would say r to the 6th. Then I'm going to move on to my x term, and I have x squared and an x squared. So x squared times x squared becomes x raised to the 2 plus 2, or 4th power. And now I have my last one, which we will use this. I have d to the 3rd and just a regular d over here, so this is d to the 1st. And then 3 plus 1 is 4. So my answer is 24 r to the 6th, x to the 4th, and d to the 4th. All right, now I want you to try this one on your own. Good luck. All right, hopefully you ended up with negative 35, a to the 10th, b to the 14th. You got that by saying negative 5 times 7 is negative 35, and then 4 plus 6 is 10, and 12 plus 2 is 14. Okay, so if you have questions about that, please be sure to reach out for some help. I'm happy to help you. Let's move on to our next power rule. This is what's called a power of a power. So in order to find a power raised to another power, you're going to multiply the exponents. So this time, notice that my b only appeared once. My base only appeared once. And then there's parentheses, and there's an exponent next to an exponent. Whenever that happens, you're going to multiply. Okay, so this becomes b to the 3rd times 4th. And one way to think about it, if you're wondering why that is, this is the same thing as this, which would be b to the 3 plus 3 plus 3 plus 3, or b to the 12th. So you can see it's faster to write it, or faster to multiply rather than writing it out like this. Okay, so now let's practice some problems like that. So here you can see I have a lot of powers to powers. So what I would do is I'd say 2 times 2 is 4 times 4 is 16. So I'd say x to the 16th power. Then here, these are the same exponents, so I know it would be 2 to the 16th. And sometimes when you get a number, a regular number raised to an exponent, your homework is going to expect you to simplify that number. So on the calculator, you would type 2, you'd use the caret key, 16, and then you'd hit enter, and you would get the answer 65,536. Okay, so make sure you read the directions to see which way it wants your answer. Usually it wants you to write it like this. Sometimes if it's too big of a number, so let's say the calculator gives you something like this, and you get an E. Whenever you get an E, what that means is it's scientific notation, and it means it's moving the decimal 14 places. So that's a bigger number than I'm going to make you write out. So if you ever get something like this, you want to leave your answer with the number raised to whatever exponent gave you that number. All right, so now I want you to solve this problem on your own. Good luck. All right, for this problem, hopefully you said 3 times 5 is 15, times 2 is 30, and then if you plugged 3 to the 30th power in on your calculator, you got one of those examples where you got a decimal number with an E. So too big to actually write out, so you can leave your answer like this. So 3 to the 30th power. All right, moving on to our next rule. So this one is called power of a product. So it's kind of combining the two things, or combining the two things that we've talked about already. This is essentially the distributive property for powers. So that means that if you look inside your parentheses, this is -2 to the 1st power, x to the 1st power, y to the 3rd. So you distribute to all of your exponents. Okay, so you would have -2 to the 5th power, or raised to the 5th power, and then x to the 5th, y to the 15th. And then I want to simplify this, -2, which when you plug this into a calculator, you want to make sure you put parentheses around the negative and 2 before you hit the caret key and type 5. Otherwise, sometimes your calculators do a weird thing where it will give you the wrong answer. So if you do that, -2 to the 5th power, you get -32. And then I can't combine my x's or y's, so I leave them. And now I'm going to show you another example like this. So it's the same idea where I have 3 to the first power, x to the first power, y to the second, z to the third. I multiply. So if this becomes 3 to the fifth, or if I type that into a calculator, I find out that's 243. And then 5 times 1 is 5, so x to the fifth, y to the 5 times 2 is 10. And then z is raised to the 5 times 3, or 15th. So that would be my final answer. All right, now I want you to try this one on your own. Good luck. All right, for this problem, hopefully you said 4 to the 4th power was 256, and then you got h to the 12th, j to the 4th, and k to the 8th. If you have questions about that, please be sure to reach out for some help. I'm happy to help you. Let's move on to our next example. So now example 4 is us putting everything that we've talked about so far together. All right, so if I look at this first set of parentheses, there's nothing that I can combine or simplify. But if I look over here, I see I have some powers to powers, and what I need to do is I need to simplify that first. So I'm going to leave the 3xy to the 4th as is, and then I'm going to start by distributing this 2. So negative 2 squared becomes 4, and then y to the second power, or y to the first times 1 times 2 is 2. All right, and then that's all raised to the third power. So what I can do is say 3xy to the 4th, and then I can say 4 to the 3rd is 64, and then y to the 6th. Then from there, now I can combine, and I'd say 3 times 64 is 192. And then there's only this one x, so I'm going to put x, and then y to the 4th and y to the 6th. Since the y appears twice, I'm going to add my exponents. So 4 plus 6 is 10. So this would be my answer. Now I'm going to quickly show you another way that I could have done this problem. So another way I could have done this problem was I could have kept 3xy to the 4th, and then what I could have done right away is said 2 times 3 is 6, and then I would distribute that 6 to each of these. So it'd be negative 2 to the 6th power, which would just give me 64 right away, and then I would have y to the 6th. So then you can see that you would multiply just like before, and you'd get that 192. There's only that one x, and then you would add your y exponents. So that's a slightly faster way to do it. I know sometimes you guys are more in the habit of kind of doing one set of parentheses at a time, which is why I showed you that first way, but you are more than welcome to do it this second way as well. It's a little faster. All right, now I want you to try to solve this problem on your own. Good luck. All right, for your problem, hopefully you got 144, a to the 4th, b to the 10th, c to the 2nd. The way you got that was by saying 4 squared was 16, a to the 2nd power, and then 5 times 2 is 10. Negative 3 squared is positive 9, and then these were both powers of 1, so times 2 becomes a squared, c squared. And then you said 16 times 9 is 144. A squared times a squared is the same as a raised to the 2 plus 2 power, or a to the 4th. There was only one power with a b for a base, so that stayed, and there was only one power with a c for the base, so that would stay as well. All right, let's move on to our next rule. Now we're talking about quotient of powers. So in order to divide two powers with the same base, you're going to subtract their exponents. So something to keep in mind is multiplication and addition go together, and then division and subtraction go together. Sometimes that's something that's helpful for students. So now looking at this, you can see I have the same base, it's a b, and then I'd say 9 minus 5. You do top minus bottom, and so that would become b to the 4th. And that's what we're going to do. Now, you can see this is a little more tricky than what I just showed you on the last one, so let's break it down. You start with I usually just go left to right, so I would start with my regular numbers, my constants. So I'd say 8 divided by 2 is 4, and then I have k to the 7 minus 5, which would be k to the second. I have m to the 10 minus 3, which would be 7. And then if you look over here, I have a p over a p. And if we think about this, okay, you get p to the 0 power then, right? Because you'd have 1 minus 1 is p to the 0 power. And if we think about that, if we break this up into its own fraction, it's something over itself, right? So if I have 3 over 3, that equals 1. If I have 10 over 10, that equals 1. If I have x over x, that equals 1. Whenever you have something over itself, it equals 1. Okay, so anything to the 0 power is 1. And then they can just kind of cancel out of your fraction if there's other stuff on the top and bottom. Otherwise, you sometimes have to put a placeholder of a 1 on the top or the bottom if everything else cancels. So make sure that if you have the same thing on top and bottom, those just cancel out. So then I'm left with a 4k squared m to the 7th. And if I put the 1 there, like these are all multiplying anyways, so it'd be 4 times 1. So it'd just be 4k squared m to the 7th. So that's what I mean by cancel out, is it doesn't necessarily appear in your final answer. All right, now I want you to try this one on your own. Good luck. All right, hopefully you ended up with 8d squared c to the 4th, and you got that by doing 72 divided by 9 is 8. And then d raised to the 9 minus 7 is d squared. And then c raised to the 12 minus 8 is c to the 4th. So putting those together, you have 8d squared c to the 4th. All right, now let's talk about the zero exponent property. I just kind of told you about this in the last example. Anything raised to the 0 power is equal to 1. Okay, so if you ever see this, it doesn't matter what is being raised to the power of 0, its answer is 1. It can look super complicated, like it could be a really, really complicated something in parentheses be raised to the 0 power, and it's still just going to equal 1. Like you don't even have to care what's in the parentheses. If you see this 0 power and everything is included with the 0 power, you just write down 1. Okay? Why don't you go ahead and try this problem on your own? Good luck. All right, hopefully you said, well, that's easy. It's 1 because everything's raised to the 0 power, and you would be correct. So hopefully you didn't even bother trying to simplify the stuff inside the parentheses because it doesn't matter. It's just 1. All right, let's now look at the power of a quotient. Okay, so in order to find the power of a quotient, apply the power to the numerator and the denominator. So this would become 4 squared over 5 squared. Okay, so that power, that exponent, gets applied to both the top and bottom of a fraction. So this would simplify to 16 over 25. Now if I were to go down here, this would become 2 to the 4th, which if I simplify that even, 2 to the 4th is 16. And then 2 times 4, that would become an 8. And then 4 times 1 would be 4. And then I have 7 to the 4th power, which is 2,401. And then 1 times 4 would give me x to the 4th power. Now from there, I simplify. And I'm going to tell you, I picked these numbers at random, and I discovered that 16 and 2,401 do not actually simplify. So we're going to leave those. Okay, and now I look at my exponents, and I say x raised to the 8 minus 4. Sorry, that should be minus. That would be x to the 4th. And then there's only the y on top, so it stays. So this would be my final answer. All right, now I want you to try this problem on your own. Good luck. Okay, for this answer, hopefully you ended up with 4y to the 4th over 9x to the 6th. If you have questions about that, please be sure to reach out for some help. And let's move on to our last example for today. So negative exponents. For any non-zero base, So that means this cannot be 0. A negative exponent gives the reciprocal. So what that means is 2 to the negative 4th power is actually the same as 1 over 2 to the 4th, or 1/16. Down here, I have 1 over y to the negative 4th. So the reciprocal means that that would flip, and this would become y to the 4th. And you wouldn't have to write it over 1. So the reason we do that is because in order for an expression to be fully simplified, you can't have negative exponents. So when you flip it up to the reciprocal, it makes it a positive exponent. Okay, so if the negative exponent was on top, it goes to the bottom. If it was on the bottom, it goes to the top, and that's how they become positive. So let's practice that. All right, so I have this expression, and I'm going to start by just moving all of the negative exponents. So I have 2a to the 2nd, b to the 3rd, and I also have 10, and then I have another a to the 3rd, or a to the negative 3rd, so that would move to the top because it was on the bottom. I have a b to the negative 1 that was on the bottom, so it's going to move to the top to become positive. And then that c to the negative 5th would move to the bottom to become positive 5. And then the c to the negative 4th would move to the top to become positive. Okay, so now I have everything is positive exponents. So I'm going to start simplifying. First, I'm going to start with my regular numbers. 2 over 10 as a fraction becomes 1 over 5. So I'm going to put a 5 on the bottom, and then I'm going to put a 1 on the top. Okay, so I've done something with those. Now I have my a term. I have a to the 2nd times a to the 3rd, so that becomes a to the 5th. Because my base appeared twice, so I add my exponents. Now my b term, I have b to the 3rd times b to the 1st. Again, my base appeared twice, so I add my exponents. 3 plus 1 is 4. Then I'm left with c's. I have c to the 4th over c to the 5th. So remember, you do the top minus the bottom, and you would get c to the negative 1. So in order to be fully simplified, I would need to move that c to the negative 1 to the bottom. And this would become my final answer. Now I have a couple tricks when it comes to the division of exponents. Sometimes students don't know if it should go on the top or the bottom. The simple answer is it goes wherever the bigger exponent exists. Okay, so in this case, 5 is bigger than 4. So I should say it goes wherever the biggest positive exponent exists. Okay, so you already have to have the positive exponents for this to work. Okay, so since 5 is bigger, I know my answer is going to be on the bottom. That c is going to be on the bottom. And then the way to know what power it's raised to is you just figure out how far apart are 4 and 5. They're only 1 unit apart, so I know it's going to be raised to the first power. And like I already said, 5's the bigger exponent, and it's on bottom, so it's going to be on the bottom. Okay, so hopefully that's a little helpful. I know that can get confusing. Feel free to ask lots of questions. I'm happy to help you guys. I love this stuff. I think it's super fun. So happy to help you. Now I want you to do the last problem of today on your own. Good luck. All right, hopefully you ended up with r to the 3rd over n to the 5th times p to the 3rd. And that is your final answer. And I realized I have one more thing to tell you guys that I haven't said yet in this video. Sometimes students will ask, what order do we have to put the variables in? My personal preference is trying to do alphabetical order on top and bottom. But if you were to switch these two things around, your answer's still correct as long as it's p to the 3rd and n to the 5th. Okay, so it doesn't matter which order you go in, it's still correct. Like I said, my personal preference usually just alphabetical order, but if it's not alphabetical order, you're okay. All right, if you have questions about this or anything else from the video, please reach out for help. I am happy to help you. Have a great day.